All right. This should be the blue snowball. Good. All right. All right. And yeah, turn that down if I can figure out how. There we go. All right. So supposedly participants are muted. If not, send me a chat message so I know. We have a few minutes before the official time. So as usual, I want to talk about the news. There's quite a bit of exciting news just today. This one's probably the most important one. And this is pretty interesting. This one's very relevant to this class. And, all right, so let me mention a few of these. This is probably the most important one. This came out just today. You can call somebody on FaceTime if they have an iPad or an iPhone, and if they don't answer, you can just add your name in, your phone number, and it will interpret that as them answering, and you can then hear everything they say even though they never answered the phone. You can call somebody, and even when they don't answer, you can turn on their microphone and hear everything they're saying. And you can even turn on their camera and see everything they're doing without them answering the call. It's bloody awesome. So I disabled FaceTime, and you should too. Apple says they'll have a patch later this week, but until then, anybody could turn that on at any time, and there's nothing you could do about it.
That's only if you call them, they don't answer.
That's right. If you answer, then it'll be, you'll know they're seeing you, but if you don't answer, they can answer from their end, and it interprets you as you're getting on the call. And they have videos of this. So people have been trying it on their friends and family. You can totally turn on the microphone and hear what they're doing.
The second I'm getting back on doing that.
I know. It's bloody awesome. So, and many people have reproduced this. It's all over social media. Everybody's doing this to everybody. So that's about as scary as it gets. That was when people first had smartphones. They said, wait a minute, that's a microphone. People could listen on everything I do, and they totally can if they put malware on it, or if they have like advanced nation state type hackers that can do it. But now everybody can do it. So probably by next week, we'll have a bunch of scandals coming out of this. Boy, I wonder how many people are listening on everything Trump says and the indicted conspirators and everything. Trump uses an iPhone, doesn't he? Anyway, I hope you disable this FaceTime. Anyway, so this is very interesting. I spent all day doing this. I hacked at Bank of America again today, Home Depot yesterday. They're both homework in my mobile device class because I notified these guys years ago and they don't patch their thing. But this I thought is very nice. In fact, this made a good homework project in 128. India uses an Android app, and this is the official government Android app. It's called UDI, and I don't quite know what it's for. I think you use it for like an ID card in India. Here it is. The official Twitter account of the Unique Identification Authority of India. Now, I must say, this is something Obama wanted to do. Obama announced it's too much bother for everyone to remember their passwords, so we're going to make an official government repository so everyone will log in through the government. And they didn't do that in America because that was like a terrible idea, and everyone screamed at him and he knocked it off. But apparently they've done something like that in India. And just as everybody would have predicted, they've done it wrong because the government is very bad at security. And so they totally made a vulnerable app that everybody is using for important things. And he totally shows how to do it. So you can download the app from the Play Store. Then you can totally open up the app and see the individual files like we're doing in 128. Then he can find the activity, and he was able to find documentation of it. And he found this does detection to see if it's running on a rooted phone. And he found the code that does that. And he just modified the code to get rid of it. Now he can make a modified app that runs on a rooted phone, which is what kind of thing we've been doing. That's what I did with the Bank of America app. I modified it so you steal the PIN right out of the entry screen. And so they're making exactly the same mistakes that all the banks and insurance companies and retailers in America are making in their apps, except for a few people like the NFL that have a highly secure app. And he totally explains how he did it here. It's very nice. Just following his series of tweets, you can totally do it, and I'll probably put that in as an extra credit project. Yeah.
Is he somebody that's worth following on Twitter?
I don't know. I don't know. I think I did follow him after this. It might be. This is what you do on Twitter. Whenever somebody does something cool, take a look at their tweets and follow them And then I'll always ruthlessly unfollow them if they start getting boring. I mean, it's news. It's not a personal connection so much as it is business. But yeah, totally follow interesting people like this. And so the Japanese government, this is something that's happened over and over again. This has been happening for decades. People have a lot of insecure devices, and if people have written viruses that infect them that pop up a warning, people have written up attacks that actually go on your device and fix the vuln. And several times these things have gone out of control and created a worse problem than the original thing. And it's always considered totally illegal. There were many wildcat researchers have taken over hundreds of thousands or millions of devices for a supposedly good purpose, but you're committing 100,000 felonies, technically. And so they hide. The latest one was Hacker Giraffe. Hacker Giraffe, who apparently is in India, found a vulnerability in a lot of printers, and he printed messages on them all saying, you guys should secure their printers or something, advertising in a PewDiePie or something. And then everybody screamed and yelled at him, and somebody hacked him and found his personal address and threatened to kill his family and found his personal email, and he panicked and vanished. But that's the problem. I mean, technically what he does is illegal, but this is what the so-called white hatters do. They technically, some people say they shouldn't call them white hat because they break the law, but they consider themselves heroes. They're good guys because they're not really hurting anybody. And so that's the argument. But that's not a legal defense to say I hacked you and didn't really hurt you. Maybe it should be, but it isn't. Anyway, so the Japanese government has decided to do exactly this. They want to secure the Internet of Things devices before the Tokyo Olympics because the previous Olympics decided to ban Russian athletes. And in order to punish them for that, the Russian government hacked them and put insulting messages all over the place and screwed up their internet presence. And they're afraid of this happening because the Russians play really dirty. So do the Chinese. And so they want to secure their country before they host the Olympics. So they are hacking into everybody's devices by trying default passwords, and they're arguing about this over there. Over here, the legality of it is very strange. Microsoft got court orders on about 5 specific cases. Microsoft got permission to take over botnets and run code on the infected machines, which is a similar thing. You have to get a special court order for that, and I think the legality of that is very unclear. The FBI got a court order for Playpen. They wanted to catch the pedophiles behind Tor, and they got a court order that gave them legal permission to install malware on people's machines without having any idea where those people are or who they are. And the problem is, how can you possibly know those machines are under the jurisdiction of the court making the order? How can they give me permission to hack somebody in another country? If you're going through Tor, you don't know who you're hacking. How can any court possibly have the authority to give you the right to do that? Yeah.
If the crime is taking place in the jurisdiction, regardless of where the computer is located, can that be a good argument?
You can make that argument, and what I would say is, but the only thing the court can guarantee you is that you won't be prosecuted in an American court for doing this. But if I was to hack a machine and it's in Japan, and then the Japanese want to punish me for it, I don't think the American court order will save me. So this is the problem with international borders on the internet. It's so easy to hide behind a border, and then the laws don't apply. So anyway, it's interesting stuff. And people are arguing whether they should do this and whether it's going to do any good, but they're at it. This one's particularly relevant to this class. So PHP has a curl option, and this is called HTTP response splitting. You can send a request to a server, and it then returns some of the information that came from the cookie. So what you can do, there's a server running, which runs curl, and if it repeats some of the data you put in, then you can inject carriage return line feeds, which then come back when they're echoed. And carriage return line feeds are what separates one HTTP response from another. And because people use things like load balancers and proxies, it is common that I send several requests to a server, and then later I get several answers, and I really don't know which request goes with its answer. So most browsers will let you get 2 answers in one reply and interpret it as 2 pages. So I can have the real page, and then I can eject a carriage return line feed at another page, and you'll see it in your browser, even though it didn't come from the server. Or to be fair, it wasn't generated based on stored data from the server. I bounced it off the server. By sending it up in a cookie, it returned a cookie. This is called HTTP response splitting, and it's pretty awesome. So down here we have here's the requests. You send data to the server. But if your data is long and includes carriage return line feeds, then I can make it so the reply has, here's the exploit. You send data that has, this is carriage return line feed, 0D, 0A. So now when I send the reply back, it's going to get, kind of hard to see here, but you can get 2 whole responses and you can fool people and you're seeing a page that's not there. It's interesting. And this is the kind of thing that happens with cross-site scripting. Many companies don't care about cross-site scripting because you do not really get a chance to write on the server, but you do get a chance to bounce code off the server that goes back to the customers, so they think it came from the server. And their antivirus app thinks it came from the server, and their operating system that has certain trusted URLs thinks it came from that server. So it goes through their security measures, and their software, their antivirus will then report it to them as that server serving up malware. So you can end up on a blacklist of a server hosting malware when you're not, but you have a cross-site scripting vulnerability, so people are bouncing malware off your server, so the end result is effectively you're serving up malware. And then you could scan your server hunting for the malware, you'll never find it. But you're getting blacklisted and everything. It's an interesting bit of madness.
If you disable JavaScript, does that solve the problem?
If you disable JavaScript in your browser, that solves some of it, but not this one. This one doesn't depend on JavaScript. Some of them do, though. Anyway, all right, so I think we're ready to carry on here. We're doing chapter 1, and or chapter 2, rather, and we got down to here last time. We're talking about the fundamental security problem of web apps, which is, like you just saw, you take input from people. It's coming in cookies and forms, usernames, passwords, blog posts, images. People are sending stuff up to the server, which your server then processes and sends some kind of result back out. So almost all web exploits are based on sending something up to the server that it misunderstands and does something unexpected and harmful with the input. And there's an endless number of ways to do that. So all these things go up to the server, and each one of them might contain unexpected code. So the most common solution is to try to filter out all the bad stuff. So if you have a SQL server, you try to remove the apostrophes. If you have a form, you try to remove all the greater than and less than signs so they can't put up script tags and things like that. This is one way to do it. This is very ineffective, blacklisting, because you cannot enumerate all the evil in the world. And all they have to do is modify the evil a little bit so it doesn't fit your pattern, and then it gets through. What's considered a lot better is whitelisting, where you only let things through that fit certain rules to make them safe. And you don't let anything through that doesn't fit your expectations. This is more likely to work than trying to enumerate all the bad, is to enumerate all the good. And this is what some antivirus companies do, like F-Secure. By default, F-Secure blocks every app on your Windows machine except ones that are on a known list of commercial apps they can trust. And anything unrecognized is blocked. That's how iPhones work. You can only put on apps that are from the official Apple Store. Nothing else will run. And that turns out to be much safer, also much more restrictive. You can't write custom stuff and all that. But for most end users, that's a pretty good deal. So sanitization is trying to make dangerous input harmless. So you take HTML encoding. This is also space becomes %20 and so on. This is a lot of why you have so many ways to sneak forbidden characters past filters, because there are many ways to encode characters. And the person writing the filter may not know all the encoding techniques, so there might be a way to encode it that causes the filter to not recognize the bad character. So another layer of defense is to write code which can't be fooled even by malicious input. If you write the correct kind of SQL code, which we'll do later in this class, you have code where there are no characters that cause it to misunderstand data as a command. The data goes into a data object. The data object cannot be interpreted as a command by any injected characters. That is a much safer way to write code. And if your developers all know enough to do that, then that's very strong defense. And then you've got semantic checks. This is one very weak defense, but very common. People often implement this in JavaScript in the browser. They just check to see if the data is reasonable before sending it to the server. So you don't have to waste everybody's time sending obviously broken data up. So you make sure that, account numbers have the right number of digits and zip codes and phone numbers do and all that jazz. That will save everybody a lot of time if you don't even bother sending stuff that isn't even correctly formatted off to the server. So input validation comes in. And the problem is the server is not just one object running one language. It's a whole cluster of servers running different languages. So even something that passes one series of tests as being safe might not be safe when it's passed on to the other servers. That's why this apparently simple problem just echoes over and over and over again to where almost every web app is vulnerable to just an endless chain of these. And that's why big companies like Facebook have bug bounties, and they pay out tens of thousands of dollars a month forever, because they have just an ending flood of flaws. And every time they add new features, they add new flaws, and they never can find them all, even though they're seriously trying everything to find them. There are just so many ways to be wrong that this is why it's a fruitful field for security research. And the big issue here is boundary validation. There are boundaries. There's an HTML server, HTTP server that's taking data. Then there's a SQL server. Then there's PHP code running somewhere. And each one of those has a boundary of what's coming in and what's going out. And you have to watch data coming in and watch data going out. When it leaves your environment and enters another environment, it is reinterpreted by the new rules. This is like having an English speaker collect the data, then translate it to Japanese and pass it to the Japanese system, then translate it into Chinese and pass it to the Chinese system. If it's misunderstood by the other system, then you have a security flaw. And that happens a lot. So that's the game. This is a very difficult job. Each device has the job of watching all the inputs to make sure it's not malicious and watching all the outputs to try to make sure it's not going to hurt the next thing in line. So even if your developer knows everything about PHP in the PHP app, they're also supposed to know what would hurt a SQL app. And that is asking a lot of them. They have to not only know their stuff, they have to somehow know somebody else's stuff, and that's almost impossible. This is why I think I told you Netflix came here. The security guy came and gave a talk. It was very interesting. And I asked him if he wanted to hire our students. He said, no, I don't want your interns. I don't want your graduates. We never hire anybody until they have 5 years of real coding experience on the job, because nobody learns how to do this right in any school anywhere. You only learn how to really do this with real experience to where you have really been the guy in charge of several servers until you begin to get a clue what are the real problems. So here's an example. Someone's coming in to log in, so they send the login to the application server. It then sends a SQL query to some database to see if you have the right password. Then it decides to send something to a SOAP service we'll talk about in a minute, which is requesting more information, like this might be your Facebook post to put on your wall. And so it sends it up here with SOAP, and then it sends all this stuff back to you, your profile page with your wall of posts, which is combined by several devices running different languages, and that's what you really see. So a SOAP request looks like this. SOAP looks a lot like HTTP, but it's simple object access protocol. It's a way to send blobs of data up and get blobs of data back in this SOAP thing that is XML sent over HTTP. Yeah.
You class, do you have all of these slides on your website?
Yes, and that's important. I'm sure other people have the same question. Let me point this out. If you go to my website, this is 129S, and all the slides are here.
Okay.
And that's important because you don't need to take notes or anything. And it's also, I'm following this book pretty closely. So
Okay.
it's on there. This is very good. Yep. You folks should be doing the quizzes too. You'll find the quizzes here. You have to sign up on this server, and then you take the quizzes online. And there is homework projects you should start doing, and those are down here. Yeah, so this is, yeah, very good. Anyway, so, all right. So here's boundary validation. You come and you log in with username and password. So here we try to prevent obvious bad things coming in. Then it performs a SQL query. So we try to remove dangerous characters so it doesn't have a SQL injection vulnerability. The login succeeds. Now it passes data to a SOAP service. Here we have to block XML meta characters, which would be used to attack that server. Then it displays this data back to the user. And now we HTML encode it so that we don't have scripts that we did not put there that run on the user's browser. And that's the layers of defense you have to have at every step. So here's common filtering problems. If this is filtered by matching it with, say, regular expressions, all you have to do is this. And the filter will remove the one in the middle, leaving one behind, and it create the thing you want. And there are many, many examples of how filtering doesn't really stop you. Here's another one. If the app first removes this and then removes that, then I just have to send this. So when it removes this one, it will create the string, and it will think it has already been done looking for it, so it won't look again. And I can, again, send up a strange pattern of text that results in the forbidden characters getting up to the server. Canonicalization is another one that affected Windows servers a while back. Apostrophe is %27, percent is %25. Microsoft IIS had a problem where it decanonicalized things twice. So you could send it %25, 27, and it would interpret the %25 down to a percent, creating a %27, and then it would interpret that into the apostrophe it was trying to block. So you're trying to remove an apostrophe, but it wouldn't remove this mess, which is not equal to an apostrophe, but when actually processed by the server, it turns into an apostrophe. And you can then seek it in a SQL injection form and such. So there are a lot of things you have to do to handle users. Watch your error messages off, and logs often leak out secret information. And you should have network monitoring, alerting people when you're under attack. And we'll be playing a lot with that with the red versus blue that's starting in a few weeks. We'll be monitoring attacks with Splunk. That's what people do. And other SIEM, security intelligence, environment management, whatever it is, SEIM, security event and incident management or something. I don't forget what it is. But these things that accumulate the logs and then tell you what's going on and warn you when you're under attack. I had some student take my 123 hacking class where you do a lot of these attacks. And then he came to class and said, oh, I decided to do my homework at work. And I said, oh, where do you work? He said, at a bank. I said, oh. He said, I was down there. I was going to do this SQL injection project. So I downloaded Haviz and the phone rings. What are you doing down there? Knock it off. I said, hey, that's good. That shows the proper kind of network monitoring. If somebody is downloading a hacking tool at your work, you should know that. Something should pop up telling you, you can do that. And that is really good. You'll be a lot safer if you're watching for that, instead of like next week after all the data is stolen, going back through logs, oh, somebody sold the data last week, gee. You know, that's, anyway, so often errors tell you far too much. You get this kind of error showing unexpected end of SQL command with code in it. This is very common. Poorly configured servers leak out all kinds of source code and all sorts of things when you have errors, and that just helps the bad guys. Your logs log all sorts of things, but the logs can be hack attack vectors. You can often even inject executable code into the logs and then run the logs. And you can also trick the logs into leaking out secrets. There was a fun attack a couple of years ago Troy Hunt put up. There's a thing called an LMA server, which is a Windows server log, frequently used. You can find them. Let me bring up one live here. If you Google for LMA, unless I've forgotten the name, remember the name wrong, this is it, LMA. M-A-H stands for something.
In the log. Like
yes, exactly. There are logs out here. You test error logging with LMA, and if you search through here, you'll find real live LMA logs. And if you have a more careful chosen string, you'll see it. Looks like this one became kind of well known, so they're probably not that common, but this, I may not find a live one, but anyway, for a while there were live ones, like I think Toyota had a live one. You would just view the log from anywhere, and then all you do is you send people a link with like a bad character in it, going to the Toyota website. It will go to their server, create an error, which includes their cookie, and put it in the log that everybody can see. So now you get the cookie and get in their account. This is the kind of thing happens a lot. That's what I mean. Logs are quite dangerous. And we'll do quite a lot of this in the Android class, putting secrets in the logs. It is very easy to do. The logs are not safe. The logs are generally shared by all the apps on the phone and often publicly viewable and all that jazz. So if you install Splunk correctly, they talk about how to sanitize things and limit what users are allowed to see the records for this reason, because your log might have confidential information in it. Anyway.
Can't you set up a public and private log?
You can, and you have to, but people often forget. So your logs should have a lot of information like time, IP address, and username. It may contain things like cookies. Attackers will try to erase the logs and also read the logs. So the logs themselves are a target for both read and write access.
So I can change the date and time. So
yes.
If someone says I was at work, and then when they check the log, the user says, oh, you weren't at work.
Absolutely.
The log says you weren't there.
This is why if you install Splunk, there is no way to erase the data at all, because that is the first thing the bad guys want to do. They do not provide any delete option because they would find it and you'd be sorry.
But then there will be a note that says the log has changed, modified, right?
No, there should be. That's why if you have a properly, there won't be. If you have like a Microsoft server, the local log can totally be erased and there's no record kept. If you have a proper network with centralized logging and events are sent to the centralized logger, which is configured properly, then they can't do that. And there will be a note that they tried to erase it. That's what you want to do. You have to think of that. Anyway, so it should be alerting administrators when bad things happen, like a lot of login attempts or a lot of funds transferred to and from the same account. Yeah.
So are some server file systems actually designed so that if you alter or delete data, that it will be easier to find later on?
No, not right now. But this is the one some people do is write to non-erasable media like CDs. That's one option. And this is the kind of thing people talk about blockchains being good for. So one of the applications of blockchains that would actually make some sense would be logs. Something you can keep writing to, but you can never erase anything. And if somehow something is gone, it's easy to tell. That's the kind of thing. That's why I think within 5 years, we're going to have blockchains in every company. Not public blockchains like Bitcoin, but local controlled uses for things like this. Things you want to write that you want to make sure never get erased, even in part.
What about time attacks? You know, like people program their servers to back up their stuff at midnight.
Oh, yes.
So if there's a time server attack and I change the time, and then there's no backup.
That is an issue. Yes, there are a lot of things that involve messing with time. It's a very good point. Those are all right. So your firewalls are out there. A normal firewall stops obvious attacks like things coming in on the wrong port. The web application firewall tries to stop all these other attacks, which are legitimate requests containing unusual patterns of characters like usernames with HTML tags in them and SQL queries with extra apostrophes in them. And so that's what web app firewalls try to stop, and they are famously not very effective at. It is an almost impossible job for web app firewall to detect all the strange variations of attacks coming in. But it can stop some of them. They're almost always used because they're required by PCI DSS, because when you run a vulnerability scanner, the web app firewall is designed to produce a clean health report from the scanner. This is kind of like certification, where students get a stolen copy of the test and memorize the question and pass the test. They say, there, I know what's on the test. And you could say they know what's on the test. You could also say they missed the whole point. But that's kind of what web app firewalls are for. They are for compliance, which is passing a certain test of security. And that is not worthless, but it's not as good as really being secure.
Isn't that like GM and that smog check?
Yes, it's like rigging the smog check, like they did with Toyota. Yeah. Whoever did that, it was Volkswagen. Anyway, so when attackers send a lot of similar requests, and your automated defenses should pick that up and kick them off. Like, why do you let someone try to log in 1,000 times with different passwords? Why don't you just say anybody that tries to log in more than 10 times in a minute is a bad guy? Nuke them. That's what the Berkeley Bro product does. The Bro firewall, if anybody sends malicious traffic, like 5 recognized malicious things come within a minute, it just removes all traffic from you for the next half hour. That's a pretty good defense. So then you've got a management interface. You're probably using WordPress or Drupal or Joomla. This is PHP Nuke, which is what the US military uses in the Department of Defense. I was in the DoD pen testing bug bounty program. I didn't win anything. Other people did. It was all running on Windows PHP Nuke. I couldn't believe it. I thought that got to be fake. That's what they really use. And so it's a platform just sort of like WordPress. You log in with administration, then you can adjust all the parameters. And it's got its own set of vulnerabilities, just like WordPress. So you can attack this. You can defeat weak authentication, default passwords. Often it has flaws where you can do things without really logging in. You can also just do a denial of service attack on the administration interface. That's a particularly scary kind of attack. Anyway, I've got some cahoots about this, and then we'll do at least some of the next chapter. All right. So you do not have to cahoots your extra credit because they are not perfectly implemented, but I recommend doing it. If you're going to the top 3, you get 3 points, and it can add up to quite a bit. And the main purpose of them is to keep people from falling asleep so much. So I have my favorites here, and this is 129S, chapter 2, and there it is. Okay. And I should turn on my sound, and I'm pretty sure this thing is set to randomize things. Yes, good.
What's the game?
It'll come up. I think it's kahoot.it, but it will come up on the screen in a minute. There you are. Kahoot.it, and there's the number, right. So join this. And while that's happening, I will open up a page.
I wonder what year the IP came out.
The what?
The domain, the extension.
IT is Italy. Been up forever.
Oh, okay. I thought IP.
Yeah, I know. It could be something else, but it's actually Italy. This is why I wanted to make a page with a joke about cats on the .cat domain, but that is Catalan, and Catalans are part of Spain, and they are very, very fiercely independent, and they very, very much do not want you making jokes about cats. They take it very seriously, and They say you have to prove if you get a cat domain that you're actually putting up ethnic stuff about cattle and if you're putting up something else, we'll take you down. So I gave that up.
Register your own domain with a funny extension.
Yeah, the problem is it takes $100,000.
Oh.
But there are a few people made like .horses out there. You can totally buy a domain in .horse.
Oh, some people make their own domains that's non-public or non.
No, like, if it's not public, it won't work. You have to pay $100,000 to make a new domain. A lot of people are upset about this, but that's how I can set it up. Just to make a hoops 128.
Unless you set up your own DNS server that had it.
Then it would work in your closed network. That's why Microsoft uses like .local, which is not a real domain, but it'll work like for test purposes on your LAN. But on the WAN, it's got to really be registered, and they charge you $100 grand. I guess someone thought that would prevent people from doing malicious ones up. Anyway, so I'll wait a few more seconds, see how many more people are coming. Looks like this is it. Okay. All right, so what happens when you log in? That's authentication. Authentication is verifying who you are. One of Bruce Schneider's complaints about the TSA is they focus on authentication. They make sure they know who you are before you got on the plane. And I agree with Bruce Schneider. I don't care who you are. I care whether you have a bomb. They're doing something which is not really the main point here. But anyway, that's how it is. All right, what process enables the website to remember who you are? That's session management. That's remembering somehow from request to request that is still part of the same session, and I know who you are. All right. So what does client-side JavaScript frequently do? It does input validation. It checks to make sure that your data passes certain formatting rules. It does not do sanitization. Sanitization is actually a very bad idea, although it happens a lot on the web, where you take data which has a problem, then you fix it and use it. Now, why don't you just send the user an error message and say, send me better data? That would seem to be a lot more secure, but the problem is the data might not have come from the end user. It might have come from some intermediate device, so the end user doesn't understand the problem, and you don't really know what to tell them. So you get a lot of these sanitization routines, and those make it easier for the attacker, as we're going to see. Okay, so which one requires writing code that can't be fooled by malicious data? All right, that's safe data handling. This would be your developers actually knowing how to write code that can't be fooled, which would be like the Holy Grail, if you could really do that. It's asking a lot of your developers, though. All right, what process removes the malicious portions of user input and then uses the remaining portion? But that's sanitization, for what it's worth. All right, so let me record my winners. Caitlin, I know, and that M. Hojo, I think that's a real name. Food may not be a real name. They'll have to tell me the real name if they want points. Anyway, so let's take a look at the next chapter a bit. I think we can get on track. Let me figure out how to operate my computer. All right, it's curly thing, P. There, okay, good. There are too many shift keys on the Mac. I'm always like doing a brute force through all the combinations of shift keys to figure out how to do anything. Anyway, so We're here to talk about web application technologies. Now, as a common in textbooks, the first chapter, in this case, the second chapter, kind of summarizes the whole course. So if there was a lot of unfamiliar stuff there, don't panic. That's basically the overview. Now we're going to go through it in more detail. So the first thing is, how does the web work? And so HTTP is how it all started. HTTP was designed to make it possible to distribute information through web servers efficiently at a time when servers were 1,000 or 1,000,000 times slower, and so were networks. So it was very important to have a very simple and error tolerant system. So you send a request to a server, you get a response, and that's it. You're done. The server can end the process. It doesn't have to know who you are. It doesn't remember who you are. It's one request, one answer, in sort of like the US mail. You take one letter, you deliver it, the job is done. If there's another letter, it's a totally separate job, not connected to the first one at all. This makes it easy to write a web server that can serve a lot of customers without having to use a lot of RAM to remember anything about them all. And it's fine for Web 1. Web 1 was where you just put up static data and people look at it, like images and pages, like printed newspapers. That works fine because everybody's seeing the same thing. I don't need to know who you are. But Web 2 is where people all want to log into Gmail and Facebook and you remember who they are. And that's tough. So web requests look like this. It's just a bunch of plain text. You get something with an HTTP version, and then you have the name of a host required with HTTP 1.1. All the rest of this stuff is not really required. But you often put it in. The user agent tells it what kind of browser you're coming from in case they'd like to serve a different type of web page. This is important nowadays because you might be a phone. And if you're a phone, they would like to send you a smaller page so it fits on the phone. They could, in principle, send a different page to each brand of browser if they wanted to. And sometimes they used to do that back in the bad old days when Internet Explorer was very, very different than other browsers. Now they're all very much the same, so it doesn't matter that much. And you have a lot of other things you can put in here, like a referrer. The referrer, spelled wrong, that is the official name, and you must use the official name, which is spelled incorrectly, tells you what site it came from. This can actually be a privacy problem. But the idea is you would like to know which search engines you should pay more to get traffic from. But this is not verified. It's like the caller ID on your cell phone network. You can lie about it and such. We'll play games with that later. Anyway, so get is the verb. You must have a verb and then a URL, and then the verb, this is called verb or method. There's only a few verbs used. Get is the most common. To get post is the second most common to send data up to the server. The URL is this part here, the name of some file, and it might have a question mark and then some parameters here. You could even put like usernames and other parameters in the URL. That's called the query string. Even if it's not a query, they call it a query string. And then you have a version, which is almost always HTTP 1.1 these days. So the referrer is where it came from. The user agent is the browser. And we talked about this. The host is required these days. And the cookie is in the middle. The cookie can just have a whole blob of data, semicolon separated. Username, a name of variable equals value, name equals value. You can have as much as you want here. And if you're a professional website like Amazon or Google, you'll have a lot of these long random numbers, which are things that they don't include, they're not an encoded version of your username or password or credit card or anything private. They're a random number, which means nothing to anybody except their server. It has a database. That is the correct way to identify people. Assign them a number and store it in your database on the server. So if somebody steals that number, they don't get anything useful, like a credit card number or a password. But if they have it, then you can authenticate at your server. Now the problem is people can steal that cookie off the web by stealing your phone or by stealing it from wireless traffic or otherwise. And if they do, I can get in your account. So what you ought to do is have anti-cross-site scripting protection where that cookie not only encodes who you are, but it also encodes something like your IP address. So if someone copies the cookie and puts it on another machine and connects, it will recognize that cookie is not valid from this other machine. And you won't get in. Almost nobody does that. But they should. Anyway, so here, when you get a reply from the server, it is a similar format. It tells you, the first line tells you in a number whether it worked. There's this numerical status code. 200 means the request was understood and I was able to do what you asked. That's 200, called OK. Other things are like 404, I couldn't find it. 302, the thing has moved and you have to make another request to somewhere else. And 500, a script on the server crashed. There's a bunch of these error codes, but 200 is success. And then you have some information about the server, and then you have the results down here. Here's what you got. It sent me some JavaScript, and there it is. So the server tells you information about the server software. It is not verified anywhere. In fact, it is a good security measure to put lies on the server, so it will lie about what it is. Why would you help the bad guys by telling them exactly what version of what software you're running on the server? There's no need to do that. You might as well just lie. Set cookie you can use from the server. This will set cookies on the browsers to tell them, remember who you are. Once you log in, the server will send you a cookie which you store in your browser, and that's how, and when you send further requests to the same domain, it sends that cookie back to the server so it knows who you are. That's the intention. This is a Netscape product called the Magic Cookie. They invented this system, and it became the standard on the web.
So how do you lie? When you want to lie about it.
Oh, if you lie, you just configure your server. In the server parameters, your IIS parameters and your Apache parameters, you can say what to say. If you don't fill anything in, it'll put in the real server version. You can go change it to say something else. And you should. It's an elementary security measure. Just like you should change the default SSID of your router. If your router says Netgear, you should change it to Linksys or something. So there's no reason to help people by telling them which brand of router you have. Anyway, so you have the response comes down, it tells you whether you're supposed to store this response, and it tells you when it's going to expire, how long to store it, because browsers cache a lot of input because internet connections tend to be slow and unreliable. So when you look at a page, a significant part of that page often is remembered from the past from this to make you web surfing faster. Then you have message body down here, which contains data. This, after you have a blank line here, that's why carriage returns are super important. Carriage return line feed makes the blank, and this is now the data, which is described up there. So it tells me this is application JavaScript that goes down here. It could be a variety of different kinds of data, and that would appear here. So get retrieves things like web pages, images, cascading style sheets, Flash videos, and such. And whatever is in the get URL is sent and logged at the server and saved in the favorites on your browser, and in general not supposed to be secret. You can put usernames and passwords in the get query string, but you shouldn't, because they are not treated very safely at the server or logs or proxies on the way. They're expected to be just a file name. Post is what you're supposed to use for that, to send up things like usernames and passwords. And the parameters here don't get saved in logs and in favorites. Let's see, I've got a chat message coming in. If you used Python, would it still send you a cookie? Yes, it would. If you use Python, you're sending a request, and you can send a cookie and it can send a response. Now, if you wrote your own browser, your browser might not implement cookies, but the response will have the set cookie. And you won't be able to reach authenticated resources unless you remember that cookie and return it. That's good. And here it's someone saying legal to hack US devices outside the US. Well, that is, actually, I tried this. There was a server in Belize stealing Husmail passwords, and I happen to know there are no cybercrime laws in Belize, so I was going to hack in and steal them back. And I asked my lawyer, and he told me, if you hack a server in Belize and steal their stuff, you'll still be prosecuted in America under American law, because it's a violation of American law to hack somebody's server, even when they're outside American jurisdiction. I'm like, this is like no fun at all. That doesn't seem fair, but that's apparently the way it is. I think now if I went to Belize and hacked it and never came back, then I would probably still be violating US law, but they wouldn't be able to get me unless they actually want to extradite me from Belize, which would be hard. But you know, no fun here. So I didn't hack it. But anyway, a whole lot of fun projects are illegal. This is a constant problem with this business. Anyway, yeah.
Why didn't you just set up a few like shadow IP addresses and just bounce off of them?
That's not getting caught. That could be done, but I'm not willing to do that. I don't want to hide anything I do. I'm a very public figure. So I only care if I can do something and then blog about it and give it to students for homework and all that stuff. I want my stuff to be legal enough to do openly. You certainly could do things like tore to hide so you don't get caught. And that's one way to go. And that's the way a lot of people do things. But I'm not trying to do things like that. I don't want to do anything that I can't publish to the world.
Is Tor actually effective?
Tor makes it very difficult to figure out where you are, but not impossible. And the main group that can find you is still the US government, because most of the Tor servers are actually US government controlled. So you can hide, but they have to work harder to get you. So it is somewhat effective. Yeah.
What if you have like a VPN on someone like Hong Kong? Is that effective?
If you have a VPN to another country, then you are trusting that server with your data. So it is whatever would cause them to hand it over. And if it's a cheap VPN, they probably take bribes from anybody to hand it over. And they might even use an insecure protocol that people can hack into. But you know, you might be all right if it's a country where you feel like you can trust them. Yeah.
Also, if you're hacking like a server in Belize,
and they see that you are acting between the hours of 12 and 1 a.m.
Oh, yeah.
You know, and then they see, oh, you have a connection during that time. It's pretty easy to figure out like who's doing it. And that's how they get a lot of Tor users.
Interesting.
Yeah.
Yeah, by traffic analysis, by comparing correlation. Yeah. Yeah.
How do you get tripped up? They say, oh, that's like that. How would you get?
Well, the usual way they get you is through non-technical means. You drag, and then your buddy turns you in because your buddy gets busted for something else, and they roll over on you to get a lighter sentence. That's usually how you get it. Your friends betray you. Now, 90% of the time, that's how hackers get caught. If you're a lone wolf, you can get away with it if you're very disciplined. That's what the Jester does. The Jester has been committing enormous offenses against very scary people for 10 years, and nobody can find him. But he is not an amateur punk. He is a professional military person who planned this in advance, like a military operation, and he apparently has never slipped up. But he attacks Islamic terrorists and the US government like crazy. Many, many people want to catch him, and nobody can find him. But you have to be very disciplined to do that. And almost no hackers are that disciplined. Yeah.
Just to reiterate, it's funny that you confirm that. Is it really true that like 90% of the time it's somebody that's braggadocious or something like that?
Oh, yes. Oh, yes. Oh, ask Kevin Mitnick. That's why if you think you can trust your friends, but the fact is your friends will then get caught doing something stupid like stealing credit card numbers, and the FBI will say, we don't really want you, turn in this other guy, and we'll give you a lighter sentence, and they will totally roll over on you.
Or if there's a reward, they want the reward.
Well, that's the reward, yeah.
$1,000.
Yeah. That's what they all say. That is the main way they get you, is your friends betray you. It is possible to find you with technical means, but that's not the easiest solution. And this, of course, is another fundamental thing. No security measure on your computer can protect you too far. All it can do is mean they can't steal the data off the computer, so they'll steal it another way. I could just sneak into your house and watch what you're doing. Then what happened to all your encryption? You know, yeah.
You said most of Tor servers are U.S. government?
Yes, U.S. military. This is something that Tor users discover about every 2 years. They discover it's funded by the Navy, and the U.S. military is running almost all the servers, and they can totally see all the traffic, and then they freak out, and then they forget it again. And another 2 years, they say, wait a minute, this is a military operation. We're handing our data to the government. And they knock it off again. This is the way criminals are. I used to be married to an undercover narcotics officer, and she said, it's fine if people suspect that you're a narc. As long as they're not sure. They'll like say, oh, they feel like a narc. Don't tell them anything. And in a couple of days, they'll just get bored and tell you everything again. I've seen it happen in communities. When Sabu got caught in LulzSec, they were hacking everyone. They were hiding from the government. And Sabu suddenly vanished for 3 days. And everybody said, oh, my God, he got caught. Then he came back, and they said, don't tell him anything. I'm sure the FBI compromised him. And 3 days later, he said, oh, well, I guess he's okay. He just told her everything. And that's exactly what happened. The FBI arrested him. There were FBI agents on there. They put monitoring. You have to totally go back on and convince all your guys to perform new crimes so we can get the evidence. They were monitoring and they were controlling everything. And everybody knew it, but it didn't stop them because they weren't sure. Because they like doing it. It's fun. So if there's like a disturbing thing in the way of the fun, they will pretty quickly find a way to push that out of their mind and keep going. Another one was Agent 47. Agent 47 hacked everybody in like 2012. And then he decided one day, well, I'm not going to be a criminal anymore. I'm going straight. And 2 years later, he started publishing fictional stories about his exploits under his real name. Then they busted him, and everyone came to me, you rotten bum, you doxed him. I said, I didn't have to dox him. He doxed himself. Just the fact that you say you've gone straight and it's been 2 weeks does not mean that all the engines of law enforcement hunting you down forgive you. And it takes them like 2 years to catch you anyway. So you think I've gone straight and I got away with it, whereas what's happening is they're just still tracking you down. And there's this monster coming after you that's unstoppable. Yeah.
I'm sorry, I just had to ask. Can you elaborate a little bit about Tor being owned by the military? Because it's fast, I never do that.
Yeah, I'll find some links and show them to you next time. It comes up every couple of years. It's a big deal. It was designed by the military for this reason. The purpose of Tor is for spies in foreign countries to send data back to the government. And they said, we can make this, but it's going to be this weird encrypted traffic, so they'll catch our spies. So what we need to do is get a bunch of idiots to use it for some other purpose for our spies to hide behind. So we'll make it public, so everybody starts downloading porn on it, and that'll be a flood of idiots that our spies can hide among. And so by using Tor to commit minor crimes on the internet, you are patriotically protecting our spies. Yeah.
So I just got a text from Travis.
Yeah.
So the WRCCDC made a mistake on the Twitter. And so we're actually 6th in terms of up services.
I wondered about that. Yeah. Well, that's good to hear. Yeah, we did the CCDC and we got a surprisingly low score, and I was confused. So that's good. It's a little better.
How low was it?
Well, we were like in the lower half, and it seemed like we were doing a lot better than that. That's why.
You just get 50%.
Yeah, there's a problem. That's one of the problems with that competition is transparency. The scoreboard doesn't tell you the accurate score, which is, it seems to me, in a game that is a serious flaw. You don't have a football game, 100 points. These guys have 50 points. They're winning, and then tomorrow they say, "Oh no, the other people win." But anyway, that's why I'm making my own competition. That's red versus blue, where they'll have a scoreboard that's accurate. That's my goal. Anyway, so all right. So you send data up with a post. Let me just see the time. Maybe we should take a break. Not quite yet. Let's see how much more of this there is. Oh, quite a lot. Okay, I don't think we'll finish this chapter tonight, but that's all right. We got a long semester and some extra time. So head returns just a header from the server, and there's options. So let me do a couple of these live. Let's demonstrate them while we're at it. So if I bring up let's bring up just a Mac shell. So this is just a terminal on my Mac, and we can connect to servers. And if I use one of my unencrypted servers, that's the easiest way to demonstrate. So let me make this big. Okay. So I can do netcat to say my server.info on port 80. And when I do that, now I can send data to the server. So I can do get/http/1.1 and then post ad.samsclass.info and then enter. That completes the request. And when I completed the request, it worked, because here's a bunch of HTML. So I completed the request. It was a valid request, so I got a 200 OK. Then I got information from the header telling me what version of stuff it's running. This is a default install of Ubuntu, not updated. It is deliberately insecure and unreliable. So I did not do any of those security measures. I said it's telling you exactly what version of Apache I'm using for the convenience of my students. And if you hack this thing, it's good for you. Your project will be hacking these servers. And if you find new ways to hack them, you might get special mention. So now it sent me 2,800 bytes of data after a carriage return line feed, and down here it all is. All this HTML full of details about the page. So that's the get method. Now I could send the options method. Let me just copy this, which is kind of annoying to type. All right, and now let's do the netcat again and do options. I think you still have to do this. I'm not sure. Then this has to be there. Okay, 200 OK. It's understood my options request, so it tells me what I'm allowed to use. Get, head, post options. That's typically all you get, is get and post, and maybe a couple other things. There are a few insane ones like put, which puts data on a server. Now, normally you don't want to let people do that, but it is used by cell phone apps to put data up into it, like stores profile information up and such. There are some people that use it. But anyway, so I can do get and head and post an option. Let's do head. If I connect again and send head, gotta spell it right. All right, then this is what head is. It's just the header and nothing else. So all you get is the server version and the time on the server and such. By the way, I'm amazed I haven't screwed one up yet, so let's mess one up. If you do this, I know, that's the idea. If I make a mistake, let's see what happens. Okay, and what happened here was, it gave me 501 not implemented. Now this is fun. What should happen, you get various errors when something's wrong. We're going to see many servers, in fact, take any unrecognized word and treat it as get. This will turn out to be very useful to hack into servers later. My server is not doing that. It's just a default Apache. But we'll see later quite a few devices do. So you can use strange wrong verbs. Another thing that frequently happens in Apache config files is I block certain directories to get requests, but they're not blocked to post requests or options requests. So you can actually penetrate supposedly forbidden areas, because it's very easy in the Apache config files to make mistakes and not understand it. Like firewall rules. When we did CCDC, we had people on a Windows server, and they tried to implement firewall rules the way you do on Cisco. On Cisco, you say allow port 80, and then the last one is deny all, because it implements rules, and when it finds the first rule that matches, it doesn't look at the others. But Windows servers do not do that. So if you allow 80 and deny all, you blocked everything. So they did that, and then the server went down. They said, why is the server down? And this is one of the gotchas. Different devices have different interpretations, which can get you in trouble. So anyway, here's the URL, has a protocol, then a : / then a host name and perhaps a port number, then a path and a file, then question mark, and parameter equals value. If you don't tell it the port, it will use 80 for HTTP and 443 for HTTPS. And those are mostly what people do, but a great number of people put test demo pages on the website with a :8000 or :8080. You can often go to a website, put a :8080, and you'll see like a partially finished next version that might have vulnerabilities. One of the first pen tests I did was somebody that put up a server and they said, check my server. And all I did was notice the login page said login 3. So I went back to login 1 and login 2, and those were easy to get in. And then I was totally in control of their website. They said, how did you do that? It's often the case, that there are files on the server that shouldn't be used, but they haven't been removed. They're still there hoping you won't find it. This is the vulnerability called insecure direct object access. There is something available that we just hope you won't find, instead of removing things that shouldn't be there. So I think I'll do RESTful URLs, and that's probably enough for today. But this is another horrible thing about the web. Even protocols that are established do not have standard conventions of how they're used. So people write all kinds of different ways to interpret it. So here's the standard way to do this. You have the protocol name, HTTP, then you have the name of the server, waapp.com, then you have a /, and this search would be like a folder or a file, then you have a question mark and then parameters after that. So you can do that, and that makes sense. But for some ungodly reason, people invented this RESTful server where you take the make and model of the car and you put them in here with the / so they look like folder names. Now, I don't know why they torture us with this. How am I supposed to write a web app or firewall or a proxy server or any kind of device that interprets this if you don't even have a standard way to put the information on there? But this is the way it is. There's these RESTful, and there are several different ways to do it, and there's nothing to prevent you from writing your own and, like on your mobile app, sending the data in some bizarre way and having it interpreted. But it will mean that the firewall, the web app firewall, the proxy server, everybody's anti-spam devices will all be befuddled by it, and you'll be sorry. This is like when I used to do physical electronics. I had students ask me, why don't I just put the ground as red and the hot one as black? And I say, that would be fine if you were the only person on Earth. The problem is someone's going to connect it to another device, and then you'll be sorry you did that. But unfortunately, people do not have standards here. Yeah?
The bottom line is easier for you to arrange a file system on the server.
Well, I don't know. They're going to be looking for a folder named forward and a folder named printout, and it's not there. It's a parameters, not a folder. Yeah, but it's not a folder. It's a parameter. Make equals. Is it? No, it doesn't have to be. It often isn't. It could be your username and your password. Yeah.
So the reason why this is a thing is because the standard does not say that the extension of the address has to be a file or a folder.
Yeah. Yeah. You can put any kind of data anywhere in here, and people do, and that makes it really hard to know what's going on. You can filter out something that looks wrong, and it can turn out that that was somebody's idea of how to do it. This is another reason why you have so many problems on the web. It's like you not only have people in English talking to people in Japanese, talking to people in Chinese, but then they have weird slang distortions of their language at each level. So I got on the first set of Cahoots. That's a logical place to make an end, I think. Maybe we'll do a little bit more after the break. So let's take a look at the 3A Cahoots. All right.
The next time you can show the Windows version of login through HTTP, where you put your username and where you put the password.
I'm not sure about that. Yeah.
There's a way to log in.
I think the scores are not resetting to 0. So if somebody did good.
Scores? The Kahoot scores?
It's cumulative over each.
No. It is? Is it cumulative? That's interesting.
It all happened today or what?
Well, if so, it's been happening for years. I never thought of that. It's cumulative? Well, we'll know because there's about 1,000 points in a question. So after the first question, somebody will be 5,000 or 1,000. We will know. I'm going to watch. That's interesting. If that's true, that's interesting. Well, I could probably fix it by opening a new browser tab for each Kahoot or something. That's if it is actually cumulative. I really don't think so, but I haven't ever tested it. Let's see. There are ways to hack this too.
Well,
it has to.
There's some weird, like on the top 3,
Yeah.
saw that one person got 4 out of 5.
Oh, that's because time counts. It's not just how many you get right, it's how fast you are.
Oh,
And there's like 1,000 points per question.
okay.
So, oh yeah, it's
That's why
not
I thought
that
it
it's
was
cumulative,
maybe
but it is not as simple
Keeping
as,
it cumulative by, like,
no, it's not as simple as just getting right. It's rating you by your speed of response. Good, okay, good. Then I feel better. It's not intended to be, but that's why I made it extra credit, because it's seriously not fair.
Normally there's 6 digits in the pin, there's only 5.
Yeah. That's why the Kahoots are just intended to keep people awake. Your real tests are delivered another way, because I don't want to count your grade to a significant amount from this system, which is pretty buggy. There could be someone connecting in online with like a team of 5 people collaborating on a Kahoots, and I have no way to prevent that. So, you know, it's not by any means perfect, but it does stop people from falling asleep. That's all it's for. All right, so I think we can go. All right. All right, so what part of this is often get? All right, that's the verb. All right. What method requires user confirmation when you go back? Yeah, that's post, which I think a lot of people know. I forgot to mention in the slides. If you go back, you repeat the previous request, which is normally okay. But if it was a post, you might have been buying something, and going back would not buy another one. So the browser warns you before it repeats a post request. And what parameters are stored in bookmarks? All right, the query string is stored in the bookmark. All right. And which of these is a RESTful URL? Okay, that's it, RESTful. And by the way, these are not random. Of course, these are all ways you will really see this data going up to the server. This is the probably canonical one, where you have a question mark, ID equals 112 and type equals students. This is XML, ID and /ID, and this is JSON, JavaScript notation. You will see this data sent in all these forms all the time. And so now, if you're writing any kind of device that interprets it, it is difficult to decide what the delimiter is and when things are syntax errors and all that jazz, since people don't use one standard way to do it. But that's where we are. All right. So I got Caitlin. I think I'll do one more section today so we don't fall too far behind at FaceTime. All right, I got a chat coming in. Might be identifying someone. FaceTime is Travis. Okay, good. Good. All right. And I got your report of a Bowne. We got to talk about that. That's great. It's a very good report, and I'm going to see it presented to the class. We should talk about it. Anyway, in my Android class, I gave him a project where you have to audit an app, and he audited an app and found this awesome stuff. Anyway, so let's do one more section. So HTTP headers. Just let me hit a button to try to get this thing to go off the screen. Okay. Yeah, I think it will shrink eventually. All right. So you got a connection that tells it whether it should keep the connection open or make a new TCP connection for each one. Encoding tells you whether it can zip data and so on. Content length is required. You must tell it how many bytes of data there are. Content type tells you information like whether it's JavaScript or HTML or what it is. And there's encoding you can use, like chunked encoding. We'll talk about that. And you can tell many other things here. We'll play with these in a lot more detail. Here's the referrer we talked about. And there are other things like cookies are the main thing to think about. Then there's response headers. You can use set cookie to set a cookie. And you can use X-frame options to specify how this should be put in a frame. This is how you prevent a series of attacks that involve causing a browser to take data from one part of the page and apply it incorrectly to another part of the page. Some of these headers, when used in a modern compliant browser, will prevent certain kinds of attacks, and we'll play with those in the future. So cookies are the main way you identify people, and the cookie is set by something like this, tracking equals this number. Then your browser will store that somewhere, usually in a text file. And then every time you send a request to that URL, it will do this. This gets you to an all-important thing called the same origin policy. All security on the internet relies upon this, which is hilariously ineffective. Your browser thinks it knows where you are. Like right now, it thinks I'm at kahoot.it. So when I send a request, it will send the Kahoot cookies. It will not send the CCSF cookies. But it is very easy to trick your browser into thinking it's at Kahoot when it isn't. And so the cookies actually go somewhere else. This is very common, and almost all security on the web relies upon the same origin policy. The data is only sent to the same origin, and there are many, many ways to defeat it. And there's a general little dance that happens in security that you might as well get used to. People invent a new feature, and they trumpet it to the world. This is the security feature. This will save you. Then it gets hacked. Then they say, well, that was never intended to be a security feature. This happens all the time. The point when I found a major medical clinic, I found their password on the web. I told them, and their response was, oh, that password was not a security boundary. And the same thing with Cisco VLANs. They totally advertised it as a security problem. Then people developed VLAN hopping. So you can totally defeat it. Oh, it was never intended to be a security boundary. Anyway, this is what you say. So you can tell when cookies expire, tell how long your browser should store it. You can specify information about what domain it should be sent to if you don't want it to go to everybody in your domain, but only certain servers in your domain. You have no way to know if the browser actually does that, but that tells the browser what you are asking it to do. And you can specify, you can also tell it to send it only through HTTPS and not HTTP, which is a very good idea. Because if you don't send it with HTTPS, anybody can just steal it in a coffee house or on the network you're on. And we'll be doing quite a bit of that. You can also send it only over HTTP, which is very good. This prevents a lot of cross-site scripting attacks, which cause JavaScript to send your cookie somewhere else. And this says you cannot send it through JavaScript. It can only be sent as part of an HTTP request, which is more difficult to create with cross-site scripting. So here's the status codes. 1 is information, well, you almost never see it. 200 means it worked. 300 means you are being redirected to another place to get what you want. This is what people typically do when they make a new server or a new page. They do a 300 redirect. And if you want to see a disaster, let's take a look at who's the guy? Salesforce. Okay. So if I go to Salesforce, let's turn on developer tools. This is a good one. View toolbars. All right, we're developer tools. Tools, web developer. There we go. Toggle tools. Okay. So down here I have network, and I'm going to preserve the log, which is here. Okay, now I'm going to go to Salesforce, HTTP, salesforce.com, the insecure Salesforce page. When I do that, it loads there. It's up there, and I'm going to have to scroll back. Yeah, well, I'll let you knock off all this garbage. Boy, sure does, loading a lot of junk at Salesforce. Anyway, if I go back to the very beginning, it went to HTTP Salesforce, and it got a 301 redirect to HTTPS Salesforce. This is a very bad thing to do. And I've been using Salesforce as a bad example of this for years. This means nobody should be using HTTP for anything anymore. Browsers, I think starting last month, are going to just start warning you every HTTP website is unsafe. Even if you're not putting usernames and passwords in it, it makes you vulnerable to code injection attacks and a lot of bad things. So people should just knock off serving things over HTTP. But what many people do is they have some belief that users have bookmarks they put up there 5 years ago in HTTP, and I don't want them to be irritated. So I'm going to not actually remove the HTTP page. I'm going to put a redirect to the HTTPS page, and that'll be fine, and it's not fine. Because if you're in a coffee house and you go to the insecure page, I can intercept that request and now serve you a page over the insecure connection, and your browser does not know that shouldn't have happened. So you'll see the page and it's not secure. That's why going through an insecure step, this is like, having a door that's hanging open in your business and then locking all the other doors and saying everything's fine. And it's not. But a lot of companies do it. Instead of actually moving their stuff, they put redirects from the old stuff to the new stuff and just leave them there forever. And often it has undesirable consequences. Anyway, so
leave a
yeah.
message saying, you're missing a pass.
You could, yes. But the redirect is automatic and they feel like everything's fine because it works. This is true of almost all Android apps too. They appear to work because normal customers can reach the website and do their work. And the fact that they also let hackers get it is not visible to anybody, so nobody notices or cares. Anyway, so here's the common ones: 200 moved permanently or found and redirected. For 300s, the 400s are the bad ones, perhaps unauthorized, perhaps I just couldn't find it. Forbidden means it's there, but you don't have enough permissions. And 500 is the internal server errors, like a PHP syntax error or something. And there's people that make all sorts of fun versions, like 100 continue, 204 no content. This is a popular activity on the web, is making humorous HTTP status pages. So you can run HTTP over SSL. SSL is the encrypted protocol, and that's much better. That's what HTTPS is, although it does not use SSL, and it hasn't in 10 years. SSL was version 2, and then version 3, they're both completely insecure and got hacked long ago. It's all TLS. And even TLS 1.0 and 1.1 are largely gone thanks to Edward Snowden. Edward Snowden leaked out the secret NSA documents revealing that the government was totally hacking into TLS 1.0 and 1.1 because those used the same encryption key forever. And they're archiving all that stuff at a giant server farm in Utah. So they're collecting all the encrypted data they can't read in the hopes that later they will steal the key and then decrypt it all. And TLS 1.2 has forward secrecy. So every request has a different key. So that if someone hacks this one, they have to hack the next one too. They can't keep the key and use it for the next one. And everyone jumped on that because of the scandal created by Snowden dumping out the NSA's secret plans that revealed that the NSA was treating American companies as adversaries and hacking them the way we hack our enemies, which made people pretty upset for a while, but I think we've sort of gotten used to that too. Anyway, HTTPS protects your data in motion across the network, but it doesn't protect it at rest. So it's not protected when it's stored on your device or at the other end. This is why I have students tell me, I'm safe because I don't use online banking. And I said, well, that might be nice, but that does not remove the main threat. The main threat is someone will hack into the bank and steal the whole database. And you not using online banking does not protect you from that. The only thing it protects you from is someone stealing data from the network at your coffee house, which is possible, but that's not how it's mostly done. So HTTP proxies are big at both ends. This means you do not connect directly to a server, you connect to some other device which fetches it and hands it off to you. This is done to facilitate filtering and to make data faster. Cloudflare is one of the big reverse proxy services that will make local copies of your website all over the world so that people in every country will find a copy of the website close to them that loads fast, and they don't have to go all the way to your main server, so you don't have to pay for all that bandwidth and processor time. This turns out to be a big hit. This led to scandals like the one about 10 years ago when they said Microsoft is serving their website from Linux servers. And they said, how could they be so stupid? And they weren't, but they hired Akamai to be proxies, and Akamai used Linux proxies. So if you actually looked at what was handing out the Microsoft data, it was in fact coming from a Linux proxy. It was not a Microsoft product, but they sort of humiliated them for a while. The one I mentioned before, it's kind of good fun, is iCloud. All the data from everybody's iPhones, that's stored by Microsoft on Azure. Apple can't run servers for anything. They never have known how to run servers. All of Apple's data is stored on Microsoft servers. And I don't know why Microsoft isn't putting this in snarky commercials. Maybe they have a deal to not admit it. But, anyway, so HTTPS, the point of it is not only is your data encrypted, but you know who you're talking to because they had to send you an ID card, which you verified at a third party. So if someone in the middle intercepted your data and sent you a false ID card, you would detect that. So that's very important. Unfortunately, many people have browsers and mobile apps and other devices that do not correctly implement HTTPS. They do not verify the certificates. It is a very common flaw. But in my experience, about 15% of Android apps have this flaw and about 3% of iOS apps, so that you can, in fact, intercept them in the middle and they won't warn you. Because it's a flaw that most end users and managers will never notice. But in correctly implemented HTTPS, it is almost impossible to hack into. It can be done now only by people who can do things like steal a legitimate certificate or bribe one or be a government to coerce someone into giving you one. And so pretty much it takes you up to the level of major organized crime groups and nation state actors to intercept HTTPS. And that happens, but it's not within the range of your average criminal that's just trying to steal some credit card numbers. This is where I should mention threat modeling is very important. There's no such thing as perfect security, and if there were, you couldn't afford it anyway. So you have to decide, what am I really afraid of that I can stop? And if you think you're stopping the NSA, you are a fool. There's nothing you can do that will stop the NSA, and what you should do, and I recommend, is actually not commit crimes that are so horrible the NSA is coming after you. That's a lot more practical than actually hiding from the NSA. So forget about stopping the NSA. That is not achievable. Instead, say, well, I'm not a huge criminal. I'm not killing the president, so the NSA probably isn't after me. All I really want to do is stop punks trying to steal my credit card number. Now that you might be able to stop with things like firewalls and antivirus and VPNs and stuff, and that's a reasonable threat model. You have a reasonable security measure that stops the real threat you're worried about, although it doesn't stop everybody. And that's all anybody ever has. You have some level of protection, and there's always an attacker that could get through. Like, how do you know when you walk down the street somebody isn't going to shoot you? Nobody knows that. The president doesn't know that. The US Army doesn't know that. There is nobody on earth that is sure that's not going to happen. So you just have to make a reasonable judgment of how much am I worried about that and how much bother am I going to go to prevent it. And make a calculated risk.
That's like Las Vegas. Everybody thought, oh, just go drink and get married, and then we have that shooting.
Well, sure.
Right?
That's,
They thought,
I know.
Everybody just thinks New York will be dead, or here might be a possibility.
Well, yeah, that's why the random shootings really scare people, because they point out there are risks, but you could wear like body armor everywhere you go, but is it really worth that?
Yeah, right.
And that's the
Some
issue.
of that body armor was fake. There was a story long ago.
Oh, I didn't know that.
was
Oh, I heard of that.
Body armor.
Oh, yeah.
Was so crappy.
Oh,
It was used or refurbished or something.
Oh, yes, I know.
Sold or something.
I heard about that. The body armor actually shattered and made more shrapnel.
Yes.
That's pretty rude. That also happens. Often there are defenses
Those are
that actually,
donations, too.
there are defenses that actually make things worse. Yeah.
So, well, the two mass shootings that had to do with entertainment venues were both country music. So,
Oh. Well, okay.
I think that there's a lesson.
Well, it's a small sample size, but that would be nice to imagine. You could like
Well,
choose certain.
remember what happens when you play a country music album backwards. You get back your car, your dog, your wife.
Yeah. I've heard. Anyway, so you send your request, it goes to proxy servers that will then forward it, and the proxy will then connect. So there's basic authentication, which sends your password in base 64 encoding, which is not encrypted at all. So it's not secure unless it's sent over HTTPS. Microsoft has this NTLM protocol that sends Microsoft hashes. It's intended only for Microsoft servers inside a LAN, not generally used on the web. There's digest authentication and so on. These are all very weak. They're very old protocols that are not very strong. We'll be hacking them in, say, the encryption class. We're hacking all this stuff quite a lot. But they're commonly used. And if you add HTTPS on top of these methods, then they're okay. If this is your only method, then it's not much better than just using plain text passwords, because those encryption techniques are so very weak.
Honeypot proxies that we set up.
Oh, yeah. Yeah, you can totally set up proxies and see who comes in to use them. And it will be China. Kirk set up some proxies in the lab, and within like 5 minutes, people in China started surfing porn through them. So because of the Great Firewall in China, there's a huge need there for proxies. So they're scanning the internet constantly to find a proxy. And as soon as they find one, they redirect their customers to go through it. Yeah.
China's watching this on Bloomberg yesterday. China's facial recognition system is so good, so they scan your face at the airport. You don't think much about it, that happens here, but they have cameras everywhere.
Yeah.
So a guy who's Australian is there working on a startup in Shenzhen, and he jaywalked, and they sent him a ticket to his WeChat account within 20 seconds.
Yeah, and I've also heard they now have an app that will tell you if anybody near you is in debt, so you could turn them in. So China is the real big brother, like from the novels, where they have this strong idea that everyone should be a good citizen, and they have not much in the way of privacy or anything regulations to limit that. They really trust the government in a way that we don't over here in the current generation. But they're very patriotic. When I went to China, people were very happy. They don't feel oppressed.
Are you sure that you're ever saying that?
Yeah, I'm sure.
They say they deal with res.
No, the people we saw, no, it was not like that. I mean, I think there are certain ethnic groups and stuff that are oppressed, but a lot of people, they're very happy because their money has been going up and up. So the parents see that their children are richer than they are and that's what makes people happy. Their children are doing better than they were. They feel like they're going in the right direction and everything's good. That's what does it. That's what made us happy here in the 50s. When people, I want my kids to have a better job than me, and that happens, then people are happy. Anyway.
So they did it the same way that Japan did, so they're likely to debt fuel bubble, so they're likely to end up in a long-term.
I've heard this. I've heard that, in fact, there's starting to be an economic crash in Asia, and it's going to take down the world. So we'll see. That certainly could happen. Happened already in 2008. Might be time for it to happen again. Anyway.
When was the big one in Japan? 1991?
Yes, I don't know. That's something like that. You see another chat message here. If I can, whoops, somehow I'm hitting all sorts of wrong buttons.
If our banks were carrying it with that,
whatever happened to my job offer? Oh yeah, it didn't come through. My job offer in Dubai, it might still come, but it didn't. It's on hold, I think, because they're waiting to see what the Democrats do to Saudi Arabia. Anyway, I'll start this. Well, probably nothing. I think they forgot about it because of the shutdown. But anyway, so what request tells a server what web page you are coming from? What part of it tells it that? This is actually kind of nuts. You can configure your server to tell you how many people are surfing forward and then come into your page. For example, you're finding out where they came from, which is a strange thing for me to know. That's really not my business, you would think. Anyway, that's the refer. That's the way it is. So where can a server specify that a cookie must always be sent with encryption? Okay, that's in the set cookie header. You can specify secure, and that will say set this cookie and only delivered over HTTPS. Of course, you do not know if a browser actually does that, but most of the main ones do. But that's another entertaining attack that would especially work on like a mobile platform. I could poison your browser, and that's how, in fact, they caught a lot of people behind Tor. That's how the FBI did it, and it's how Anonymous did it before them. They put a page up that said you must update your Firefox. And then when people updated it, they were getting a poisoned Firefox that was sending their PII to the government. And that's, if you can get people to update their browser, then, you know, all this doesn't apply.
Auto-update a lot of their stuff, though?
Doesn't what?
Don't they auto-update a lot of their stuff?
Oh, yes. And if you don't update stuff, then there's attacks like this FaceTime attack to get you. So you're damned if you do and damned if you don't. You know, there's no easy answer. All right. So what status code tells you the page was not found?
It came across the wire tonight that Apple had a major flaw.
Oh yeah, I was showing people that earlier.
Based on conference.
Yeah, very awesome. I've disabled FaceTime. You should too.
Okay.
Here. It's in your settings. You can just turn it off, and you better, because anybody can just be listening and turning on the camera at any time, and you won't know. It's very annoying, downright rude. Anyway, 404 means you couldn't find it. And what's the transport protocol used by HTTPS? Oh, it would be a crime, yes. If you did that, I think you could be prosecuted for wiretap.
Yeah, which is like over 10
years. I don't know, you need an attorney to tell you, but I would casually think so. However, it's not the phone network. So most of the laws wouldn't apply, but some kind of privacy invasion, it seemed like you'd be guilty of something. Anyways, it's really TLS. It's not SSL and hasn't been for 10 years. But a lot of people continue to call it SSL just as a slang term, but it's really TLS. Anyway, so I'll record these winners, and that's enough for tonight. Caitlin, and MHIN, OJOS, and Stan. Oh, those are my real names. All right, so you folks should, by next time, you should be reading the next chapter. And you should be doing more of your projects. I saw several people already started doing projects and asking questions. I got scared. So by next, do the chapter 3 quiz by next week. After the 4th, you'll start losing some points for late quizzes and late homework. Nothing until after then, because people are still adding. I recommended this stuff you do today, but you're not going to be punished until after the 4th because, I don't want people to add and already be late. But anyway, so start doing your projects, and you'll find all the projects down here on the page. And for quizzes, you have to get on my server, where there's a link here to lead you to my server up at the top, this thing here. It is not the City College server, but my own Canvas server. All right, I'm going to stop this share, and I'll see you next week. I'm going up to the lab, of course, for people that are here. I'll be up in 214 to help people for a while.